Welcome back. Today we will talk about work, kinetic and potential energies. So, work, if you say a person is doing work, that's a different story from what is physics work. Physics work is concerned with force application and displacement. Let's say a body of mass m is pulled by a force F bar in the direction whose magnitude is F, and the body displaces in this direction S bar whose magnitude is S, and the angle between the force and displacement vectors are theta. Then we define work done is equal to F bar dot S bar. That's the definition. And if you remove the dot product says Fs cosine theta. You have to put the angle between the two vectors in terms of cosine. F is the magnitude of F bar, S is the magnitude of S bar. Now, let's say that theta is equal to 0. That is, if they are both parallel, let's say. Let theta equals 0 degrees. Then you have work done is equal to Fs. That's it. Let theta equals 90 degrees. Let's say I put 90 degrees. Then W is equal to 0 because cosine 90 is 0. If this is 0, entire product will be 0. So, not only on the magnitude of force and displacement, but also the angle the work is dependent. So that's about work done. So generally, if you have a force is applied on a body and the body displaces, then the angle between force and displacement vectors are very important for deciding what the work done. Okay, so we have learned today about what is work done. Now I will teach you about kinetic energy of a body. Let's say the angle is 0 between the two vectors and work done is force times displacement. Okay, alright. So let's say that theta is equal to 0 and work done is equal to force times displacement. Now you know that force is mass times acceleration, then displacement. But you know acceleration is this value from kinematics. This is displacement or this is acceleration. Either you can put S is equal to the value here and A this value, anything. So we'll put S is equal to that value. So MA times V final square minus V initial square over 2A. AA cancels, you get half M V final square minus half M V initial square. This is the work done by the force. So when you apply a force on a body and it displaces the body in the direction of force, then the work done by the force is given by this equation. This quantity and this quantity are called the kinetic energy of the body, but this is final, this is initial. So this is called as kinetic energy final minus minus kinetic energy initial. So kinetic energy in general is kinetic energy of any body is half times m times the velocity at that instant of time. So at different instances it can have different kinetic energy. But at any instant, the kinetic energy of the body is half m v square. So v is the velocity at that instant of time. Since it's a v squared, you can say it's the speed at that instant of time. So speed squared, half m v squared is the kinetic energy of the body. Let's say you and your friend both are sitting in a car and your friend is driving the car. So, the car is moving on the road with certain speed. For you, your friend is beside you and without motion because with relative to you, he is at rest. So, the kinetic energy of your friend with respect to you will become 0 even though he has a velocity with respect to the road. So, if you want to say about kinetic energy, it's very important with respect to what reference frame you are talking about. For a person on the road who's seeing your car passing by, he notices your friend has a kinetic energy half mv square because the friend is moving with the velocity. Similarly, you're moving. So for the person on the road, you both have kinetic energy. But with respect to each other, you don't have any kinetic energy because you both are at rest relative to each other. So that's how you should talk about kinetic energy. Okay, this is about kinetic energy. What is about potential energy? Let's talk about that. Say that you have a mass m and you displace it to a height h. Then this mass, while you're displacing, has a weight which is acting downwards. The weight of the body is acting downwards, W weight, we'll call it as FW, so that you're not confused with W. So force of weight is equal to mg and is downwards, which is like this. But the displacement h is upwards. So the work done by gravity, Wg here, suffix, equals the force times displacement. So force Fw times the displacement h, both are in opposite direction. So cosine of 180 degrees. So which will give you mgh but with minus 1 sign. So minus mgh. So this is the work done by gravity. So why did we get minus sign is the force and the displacement are opposite in direction. But if the force is in this direction, why did the body move in this direction? The body did not move, we moved it. So we applied another force. So work done by us will be the force what you apply times the displacement. But work done by gravity will be mgh. So with a negative sign, indicating that if you shift a body to this position and leave it there, then the body comes down by itself because it has a potential energy. So potential energy due to gravity is defined as mgh related to the ground. So where h is the height above the ground surface. At the ground, the potential energy is considered to be 0. So any particle at a height h has a potential energy mgh. So we have understood what is potential energy of a body, what is the kinetic energy of a body, what is the work done. We'll come back again to the same topic in the next class.